Welcome to this video on the topic of fractions. In this video, we're going to have a look at how we can compare the equivalence of fractions. Now, a fraction may be used to represent a non-whole amount. Let's have a look at what this means by a visual example. Consider we have pi. I bring in the first pi over here and we could ask the question, how much pi is represented in this picture over here? Now, if we think about it, there is simply just a whole pi available. So what we could say is that there is one whole pi. Now let's turn it up a bit and let's eat some of the pie. I bring in another pie and I look at it and I say, how much pie is here? And as you probably excellently pointed out, there is half of a pie remaining. But question is, how could we represent this as a fraction? Well, we first need to think, how many slices of pie was this chopped up into? And you can see that there's one slice, two slices. So the number of slices here is 2. Now, second question is, how much pie remains? Well, only one slice of this pie remains. So this pie, the amount of pie remaining, could be represented using the fraction 1 over 2. 1 representing the remaining slices, 2 representing how many slices the pie was chopped up into. Okay, next one. Let's bring in a pie that's been chopped in a different configuration. This pie has been chopped up into 3 slices. So the way in which I'm going to start representing this is 3 for the number of slices. And how many slices remain? Well, there is simply just 1. 2 slices have been eaten, 1 slice remains. So this would be 1 over 3. And then final example of pie. I bring in the final pie that I've cooked. And this one is similar to the last pie. However, there's more slices remaining. The way in which we represent this as a fraction is, I say, how many slices would there be? And in this case, it would be 1. And then if I look over here, I say, this is 1 slice here. So this would be 1, 2, 3. So there are 3 total equal slices. And how many slices remain? Well, 2 slices remain because there's 1 here and 1 here. It's the same as chopping the pie across like that. So there's 3 slices, and of which 2 actually remain. So this is a visual way of using fractions to represent a quantity that we could encounter. But as mathematicians, we like to find more efficient ways to do things. So what we're going to do is we're going to have a look at how we can compare fractions without having to use visual aids. So let's go down to example. What we're going to do is we're going to have a look at the method we can employ to determine whether a fraction is larger than another fraction or not. The way in which I'm going to do this is a 2-step method. First thing I do is I make the fractions such that they are represented with the same value denominator, after which I compare the numerators. So let's have a look at by example. I'm going to go example A. And what we're going to do is we are going to compare the fractions 1 over 2 and 1 over 3. Now, as a sneak peek, if we go up over here and we say 1 over 2, 1 over 3, we instantly see visually that 1 over 2 is larger than 1 over 3. But what our intention is right now is to learn the method of how we can determine what's larger using a mathematical way or using a numerical method, so not relying on pictures. So as mentioned, the way in which this will be done is first we represent the fractions as having the same denominator. Then we're going to compare the numerators. So step 1, making them have the same denominator. First thing I'm going to do is I'm going to get the fraction 1 over 2. Then I'm going to look at the denominator of the second fraction. The second fraction has a denominator of 3. So what I'm going to do here is I'm going to go times, and then I'm going to multiply the denominator of the first one by 3. Now, if I do that, I'm going to change the value of the first fraction, which I don't want to do. So to compensate, I'm going to put the 3 over here under a 3. So this is the same as multiplying by 1. So I could say 1 over 2 times 1 is just going to be 1 over 2. So I'm simply going 1 over 1, which is the same as still saying 1. But rather than 1s, I'm doing 3 over 3. So I'm just changing the appearance, not the value. Next, I actually compute. So I draw a long vinculum. I gather my numerators, 1 and 3, and they multiply together. I gather my denominators, 2 and 3, and they multiply together. Next, I actually multiply. 1 times 3 is 3. 2 times 3 is 6. So 1 over 2 is the same as saying 3 over 6. This is the first step. Next step, which I'll do over here. Next step, I'm going to get the second fraction, which is 1 over 3. Next, I look at the denominator of the first fraction, which is 2. I'm now going to multiply by 2 over 2. The intention being here is to make the denominators the same. Now, doing the fractional multiplication, I gather my numerators, 1 and 2, and I multiply them together. Next, I gather my denominators, 3 and 2, and I multiply them together. This has the result of having 2 over 6. Now what I'm going to do is I'm going to compare the fractions that I've just got. So the first fraction that I have is 3 over 6, and then the second fraction is 2 over 6. Final step, I am going to observe the numerators of both of the fraction and look for which one is higher. In this instance, I have a 3 and a 2. The 3 is clearly higher, so this means that this fraction is larger. Therefore, what I can say is that 1 over 2 is larger than 1 over 3. So in summary, we were comparing our fractions here. We had the fraction 1 over 2 and 1 over 3. We wanted to see which one is larger. The way in which we employ, or the way in which we figure this out, now the way in which we determine which one is larger using a numerical method is we get our first fraction and we multiply both numerator and denominator by the denominator of the second fraction. We get a result of 3 over 6 in this instance. Next, we do the exact same method to the second fraction using the denominator of the first fraction. This has the result of giving us 2 over 6 in this instance. Finally, we write the two fractions together and we have a look to see which one has the largest numerator. In this instance, it was the first fraction, 3 over 6, which means that a half is clearly larger than 1 over 3. Going back to our pi example, we can clearly see that this is the correct state here. So we can see that it works. Alright, let's have a look at another example that's less obvious. We have 4 over 7 and 3 over 6. What we want to do is we want to determine which fraction represents the larger value here. So what we're going to do is the exact same method we employed before. We're going to get our first fraction, which is 4 over 7. We're now going to multiply both numerator and denominator by the denominator in the second fraction. In this case, it will be 6 over, moving along, what we need to do is we need to actually do these multiplications. Our numerator is going to be 4 by 6, and our denominator will be 7 by 6. Doing the calculations, 4 by 6 gives us 24, and 7 by 6 gives us 56. So our first fraction is going to be represented as 24 over 56. Turning our attention to the second fraction, we have 3 over 6. we're going to multiply numerator and denominator by the denominator of the first fraction, in this case 7. So this will be 7 over 7. Computing this, we have 3 by 7, 6 by 7. Doing the actual calculations, if we look to the left, we see the denominator is going to be 56. It's always unchanged when you're comparing. And the numerator in this instance is going to be 21. So if we do the comparison of these two fractions, we have 24 over 56 and 21 over 56. We then have a look at which one has the higher or the larger numerator. In this instance, it's 24. So this one is larger. This one is smaller. Therefore, it can be written as 4 over 7 is larger than 3 over 6. Perfect. Okay, final example. 1.5 and 2 2/3. So we're dealing with mixed fractions now. Now the way in which we're going to deal with these is basically the same as what we've been doing in the other examples, except we're going to have an additional step here. Now, as mentioned before, we're going to use the same process, so we'll start off by getting our first fraction and go 1.5. Now we look at the denominator of our second fraction, which is 3, and what we're going to do is we're going to multiply the fraction the first fraction, such that it's going to have the same denominator. So we multiply the numerator and denominator by 3. Doing this calculation, the whole amount of 1 stays the same. I draw an extended vinculum, I gather my numerators, and I multiply them together. I gather my denominators, and I multiply them together. I complete the calculation, the 1 stays at front, and then this will be 3 over 6. So this is my equivalent fraction to here. Next, I'm going to get my second fraction, which is 2 2/3. I get the denominator of the first fraction, and I multiply numerator and denominator by the denominator of the second fraction. This will be 2 for the whole amount, and then I draw a vinculum, I gather my numerators, 2 and 2, I gather my denominators, 3 and 2. Next, I do the calculation. 2 stays at front, I get 4 over 6. So my equivalent fraction for 2 2/3 is 2 4/6. I now write these together, 1 3/6 and 2 4/6. Now previously, where we compared the numerators together, when we're dealing with a mixed fraction, we first compare the whole amounts. Now looking at this, you can see that the whole amount of 2 is larger than the whole amount of 1. So therefore, this is larger. Now at this point, you're probably thinking, why did we go through the process of making the fractions have an equivalent denominator? Well, there is no point. I was just showing you how to do it. If you see that the whole amount is larger in one of the fractions, then you can see that that's going to be a larger fraction. But irrespective, this is a showcase of how you can make the fractions equivalent when you're dealing with a mixed fraction. Now the second question that could arise is, what happens when one of the fractions is negative? So you've got -2 2/3. Well, in this instance, this would have the consequence of making this negative over here, and this would be negative down here as well. Now in this instance, we need to read the question carefully. It says, which fraction is larger? Larger implies that it is further from 0. So in such an instance, -2 4/6 is still larger. The reason being is -2 is further from 0 than 1. So this would still be larger. So in summary, what we set out to do in this lesson was we set out to be able to compare the size of two or more fractions. We first look at the analogy of pi so we can see it visually, after which we had a look at how we can do the comparison numerically. The method being, we gather our two fractions. We start with one fraction and then we multiply the numerator and denominator by the denominator of the second fraction. This gives us an equivalent fraction represented with a denominator that will be common across both of the fractions here. In this instance, it was 3 on 6 and 2 on 6. After we make the fractions have common denominators, we then compare the numerators. The numerator with the larger number happens to be the larger fraction. And then, when we're dealing with fractions that are mixed, you can simply compare the whole amounts, and if they have the same whole amount, then just compare the numerators again.